there, Math Hoppers. In this video, we are going to learn the zero and negative properties of exponents. So let's get started. I always find if you're learning a new rule, especially a rule that people don't like zero exponents and negative exponents, it is helpful to use a pattern you already understand. So let's look at some patterns involving whole number exponents that won't cause us to lose any sleep. Let's start with 3 to the 4th. 3 to the 4th is simply 4 factors of 3. Multiplied out, you get 81. 3 cubed is 27. 3 squared is 9. 3 to the 1st is 3. So what's happening here is we're keeping a base of 3, but we're lowering the exponent by 1 each time. So let's really look at what's happening each time we decrease this exponent by 1. Again, we've kept the base of 3. We've decreased the exponent by 1 each time. We started with 81. Then we went to 27, then 9, then 3. So let's think about this. A base of 3 remaining the same means we're simply multiplying by 1 less factor of 3 each time as we lower that power. So it should make sense that the pattern shows we're dividing by 3 each time. So let's use this pattern to figure out what 3 to the 0 power is. 3 to the 0 power following this pattern would be 3 divided by 3, which is 1. Remember, if we have the same number in the numerator or denominator, the quotient is 1. Anything over itself is 1. All right, so what does the zero exponent property say? It simply states that if you have a quantity A and you raise it to the 0 power, for every single non-zero value of A, the result will be 1. Anything to the 0 power is 1 for all non-zero anythings. Let's look at a few of these. The quantity -7 raised to the 0 power. Okay, so all of -7 is being raised to the 0 power. That's just 1. Now let's look at something that's similar to that, but a little different. This time the negative is on the outside of the parentheses. Okay, this negative on the outside of the parentheses is a -1 times this quantity. Anytime you see a negative out here, you need to think -1 times whatever's here. Remember, multiplication comes after powers, so we first raise 5n to the 0 power, we get 1, then multiply -1 by that. -1 times 1 is -1. 3 times the quantity 4x to the 0 power. Same principle here. Only 4x is being raised to the 0 power. Then, once you get that result, you multiply by 3. So 3 times 1 equals 3. And let's just answer the question you have now. Does this apply to fractions? Well, of course it does. 2/3 to the 0 power is 1. All right, let's use this pattern that helped us so much with zero exponents and figure out the negative exponent property. So on the screen, you see everything we've already learned, the pattern we used, all the way down to 3 to the 0, which we now understand is 1. Following that same principle, lowering the exponent by 1, we get 3 to the -1st power. Following the pattern, 3 to the -1st power will be 1 divided by 3. 1 divided by 3 can be written as a fraction, 1 over 3, or 1/3. Therefore, 3 to the -1st power is 1/3. Very interesting that the first negative exponent we got resulted in the first fraction. Let's see if this pattern continues. On the screen, we have 3 to the 3rd all the way down to 3 to the 1st. We are going to use our pattern, lower the exponent by 1, and figure out what 3 to the -2nd power will be. 3 to the -2nd power will be 1/3 divided by 3, which is the same as 1/3 times 1/3. Remember, you multiply by the reciprocal. Therefore, 3 to the -2nd power will be 1/9. In order to help us see the rule we're about to learn, I want to look at 1/9 a different way. 1/9 is really 1 over 3 squared. So if we look at this pattern, 3 to the -1st was 1 over 3 to the 1st. 3 to the -2nd was 1 over 9, which we just saw as 1 over 3 to the 2nd. So we really used this negative and did 1 over that base to the positive number. Let's see what the rule says. Negative exponent property says that if you have a quantity A raised to the -n power, it is simply 1 over A to the positive n. So a to the negative n is the reciprocal of a to the positive n, which we kind of saw in those last two examples. So let's look at one. 5 to the negative second power. So that says this should be the reciprocal of 5 squared. And in fact, it is. It is 1 over 5 to the positive 2 power, or 1/25. Okay, let's look at a fraction. 2/3 to the negative 1 power. We would never raise anything to the first power because it wouldn't change anything. But the negative first power does. The negative first power indicates a reciprocal. So instead of doing 1 over, we could do 1 over 2/3, but 1 over 2 over 3 is ugly. We would just use the reciprocal. The reciprocal of 2/3 is 3 over 2. So this is equal to 3 over 2 to the first, which can be broken out as 3 to the first over 2 to the first, but nobody would do that because it's just 3 over 2. Okay, let's look at one that's slightly different. Put up the property again. Now we have 1 over 5 to the negative second power. So this isn't 5 to the negative second power, it's the reciprocal of that. So our negative exponent is in the denominator. And I'm going to show you how we just bring that up. Let's think about this. 1 over 5 to the negative second power is really 1 over 5 squared. Because 5 to the negative second power, right? 5 to the negative second power we just learned is 1 over 5 squared. Okay, so when we have a fraction in the denominator of a fraction, well, it's a little scary, it's just ugly. So we change it and say this is the same as 1 times 5 squared over 1, which is really 1 times 5 squared, which is 5 squared. So the end result of all of this is that 1 over 5 to the negative second power is 25. Your negative exponent, if it's simply a whole number raised to a negative exponent, it's going to become a fraction. It'll be 1 over that to the positive. But if it's already in the denominator, move it up to the numerator. Let's see some more. 3 times x to the negative second power. Okay, remember, we have to separate this. 3 is not being raised to the negative 2 power. Okay, this is 3 times x to the negative second. So x to the negative second power is simply 1 over x squared. So 3 times 1 over x squared is just 3 over x squared. That's it, we're done. Now let's look at one, like the previous slide, where the negative exponent is in the denominator. So this is 3x over x to the negative third power. Let's separate it out just to make it easy. 3x times 1 over x to the negative third. Now remember, we said if we had a negative exponent in the denominator, it's a reciprocal, so we are going to bring it up to the numerator and make it positive. So this is simply 3x times x cubed over 1, or 3x times x cubed, which is 3x to the fourth power, and we are done. So basically, negative exponents switch position. If they're in the numerator, they move to the denominator and become positive. If they're in the denominator, they move to the numerator and become positive. Hopefully this video showed you why. I bet you will have questions. You just send those homework problems to our YouTube channel. You should be subscribed to our YouTube channel, by the way. Send your homework questions in that are just a little bit too tricky, and you will get a custom video solution. But until next time, Math Hoppers, have a good one.